the next thing that we're going to be interested in is how the standard deviation of the distribution of sample means varies with the sample size. So here we have plotted the distribution of the sample mean for one particular sample size, namely 10. And now we want to get an idea of how the standard deviation of this distribution varies if we're going to vary the sample size. So we're going to do this as follows. I'm going to define a vector std, which to start off with is just an empty vector. And what we're going to do is we're going to add to this vector the standard deviation of that distribution for different sample sizes. So I'm going to define a range for the sample size. So I'm going to use numpy range. And we're going to start with sample size 10, which is the one we've been using up till now. We go up to 210, and we're going to use steps of 10. So then we're going to say that for sample size, in the range of sample size, we're going to do the following. We're going to have simulated data, which is going to be equal to the same thing that we did above. So we take the mean, and we're going to take this mean over x is equal to 1. And now here we're going to have tf random dot uniform we're going to have the number of simulations, which is fixed on 10,000. So all the time we're using 10,000 here. And sample size is now a variable that varies. Yeah, so above we fixed sample size on 10, but now sample size goes over this range, which starts at 10, goes to 210 with steps of 10. Yeah, so the last number here will actually be 200 because the upper bound is not included. And we're going to use the uniform distribution between 0 and 1. And then we're going to say vector std append. So each time I'm going through this loop, I'm going to add something to the vector which I defined as an empty vector to start with. And the thing we're going to append is the standard deviation of our simulated data. So now I can actually make a scatter diagram where on the horizontal axis we're going to have this range of sample size. And then for each sample size what I'm going to plot is the vector with the standard deviations. So let's see whether we don't get an error. So basically what we see here is that as the sample size increases, you see that this standard deviation goes down. Yeah, so we can add actually some things here. So we can have an X label, which is sample size. And we can have an Y label, which is standard deviation of M. Yeah, so here you see the relationship between the sample size and the standard deviation of this distribution of M. Now in the notebook I ask you basically two things. So first thing is to realize what's the other word we use for the standard deviation of M, or the sample size, and what is the functional form of these dots. Yeah, and just to be sure, it has something to do with sigma and the square root of n. Yeah, so think about this functional form and then add this functional form to this plot. So add a PLT plot with this functional form and it will go straight through all these dots in the scatter plot.